Hello Microsoft, I am Shantini Dev, aspiring front-end developer and a CSC sophomore pursuing BTech from Siliguri Institute of Technology. I made my project under the subcategory of facial recognition system, which is object detection. I chose to make an enhanced shopping experience with visual search. It is not possible for any human unless it's a bot to recall the names of the accessories and search them. Therefore, Snap and Shop optimizes the need to search by words and help the user to find garments similar to their choice using visual search. Starting from bags, watch, shoes, dress, it has access to everything. Well, talking about the challenges I faced, I have never worked on a machine learning project before, and hence it was quite troublesome for me to come up with the project. So earlier I wanted to deploy it in the React app, but due to the limited time, I had to settle down with Streamlit. Since I was using the Kaggle dataset, I came across Git LFS problem. My Git LFS also got disabled due to heavy usage, and therefore I had to deploy the app from the start into a new GitHub account. The project is deployed in the Streamlit server, and now it's working on it, as we can see. It has an integrated sidebar to take the most out of the UI. So the main page is the home page, where the app will be first redirected to. The home page contains necessary information for anyone using it for the first time. It contains an embedded video, also a attached README file for anyone seeking the documentation on how to deploy it in their local server. Other than that, it also shows the user how to use it using some few pictures and also Lottie animations which are readily available using the Streamlit Lottie feature. The next page is the upload page, which is the main feature of this application. Now, due to the time constraint, I was not able to integrate web scraping, and therefore I used readily available Kaggle dataset, and from there I'm seeking for images and uploading it. Now I have chosen to upload a very simple dress, and now this dress will help and give us the most similar dresses which are available in the dataset, which I can say is pretty accurate. So we can say the model works pretty accurate and fine. And at the end of the page, we are here in About section, where we started from. So the About section, although it takes a little bit time due to the huge amount of data set of images, so the About section contains few information about Snap and Shop and why it was built. Now, since it's a browser-based application, it is responsive in both desktop and mobile mode. And therefore, it has all the features that we just saw in the desktop mode available by anyone who is using it in mobile phone, starting from the upload feature to getting all the recommended images. Coming to the ML part, this model uses convolutional neural network CNN and the nearest neighbor backed recommender. Once the data is pre-processed, the neural networks are trained utilizing transfer learning from ResNet 50. The inventory is then run through the neural networks to classify and generate embeddings. To generate recommendations, our proposed approach uses sklearn nearest neighbors. The similarity measures used in this project is the cosine similarity. The concept of transfer learning is also used to overcome the issues of the small size fashion dataset. Therefore, we pre-train the classification models on the deep fashion dataset that consists of 44,441 images. The networks are trained, and then the training results show a great accuracy of the model, so with low error loss and great F-score. Overall, it was a nice experience getting hands on TensorFlow and OpenCV for object detection project. The future scope is to integrate the e-commerce sites like Myntra and Amazon so that it can show the available items with direct link to purchase which are similar to the photo uploaded. This was beyond the scope of this project since it requires web scraping. Current state of the project is a prototype, hoping to work on the future scope.